Okay, thank you once again for your patience. So we're going to get started with our podcast here today, or our webinar here today. So once again, we are going to be reviewing our automated analysis ready data, or ARD workflows for commercial sensors. So before we get started, I'd just like to let you know how to engage with our team. So all lines will be muted during the presentation. To ask your questions, please use GoToWebinar's questions panel. So you can simply expand this area in the GoToWebinar application that's open on your desktop, and then type your questions into the GoToWebinar panel here. So if you have any questions about um, anything you'd like around this presentation, please feel free to enter that information whenever those questions pop in your mind. Thank you. To begin with, I'd like to just introduce our presenters here today. So we have Jason Flatt, our solutions engineer. So he's done many different webinars with us. So many of you are probably familiar with him already, but he's one of our solutions engineer and is going to be basically the star of the show today, showcasing our demonstration. Say hello, Jason.
Hello, everyone. Thank you, Sean. It's good to see everyone and looking forward to all of your questions and to present the demonstration later on in this webinar.
Wonderful. So I'm going to be your host. My name is Sean Malamed. I am a product marketing manager here at Catalyst. So once again, we're really excited to bring and showcase to you this our ARD solution. And we look forward to your questions and your interacting with you throughout this presentation. To quickly brief through our webinar agenda, so we're going to be looking at the Catalyst, introducing Catalyst. So once again, introducing our brand, introducing our offerings. So we'll quickly go through that. Then we're going to jump into the analysis ready data. So we're going to provide an overview of what analysis ready data is and the value that it can offer. We're then going to jump into our automated analysis ready data solution designed specifically for commercial sensors. And then Jason, once again, as the star of the show, is going to be providing you with a live analysis ready data demonstration to showcase to you how our solution works and what you can do with the data. And then finally, we'll open things up for a questions and answers period towards the end. So we have a lot to unpack here, so we'll just jump right into it. So I'd like to begin with Catalyst. So our mission, so our goal is once again to make Earth data simplified, or simplify Earth data. We're making actionable Earth observation intelligence available to decision makers that seek to ensure a sustainable and manageable planet. So that really here is our goal. We have a variety of offerings that are either already available and some that'll be coming out very shortly. So here is a list of the different offerings. We have our microservices, which will be coming out in the near future. We already have released or showcased our Insights product, and then of course we have our Catalyst OEM. We have our Catalyst Professional. Many of you might still know it as Geomatica. And then we have our Catalyst Enterprise, which is formerly GXL. Today, we're going to be showcasing our Catalyst Enterprise, specifically around the analysis ready data. So very quickly on Catalyst Enterprise. So this is designed to optimize and automate Earth observation image processing pipelines of any size. So this is one of the key concepts I'd like everyone to understand, is the fact that it's not just designed for large batch processing. It's really designed for any size of repeatable processing, where you can perform a repeatable workflow using Earth observation imagery. And it can either be implemented as an end-to-end workflow. So a lot of our customers use it for generating base maps and DEMs, or creating object analysis and so on. Or it can be integrated into a larger solution. So there's a variety of ways in which you can take advantage of this, and we're going to explore that a little bit here today. Something new around Catalyst Enterprise. So one of the things that really makes it very flexible for any size project is the way that we can deploy our Catalyst Enterprise solution. So this means that you can sign up for inexpensive subscriptions, and you can really scale up from there depending on what kind of processing throughput you require. We can deploy it on the cloud. So many of our customers in the industry, we're seeing a trend of people moving their data or storing their data in the cloud, so we can move the processing systems to where your data exists as opposed to the other way around. We can, of course, deploy it on site, so we still have the capabilities of performing on-premise implementations. Also, what's new around this is we can also license it by cores. So this can make it, once again, if your goal is automation and your throughput varies, you can add or reduce cores as needed in order to scale up and scale down, which is very important to make sure that you have a very cost-effective solution. And then also available in the cloud is our on-demand concept. So it really just allows you to pay for the solution when you're actually processing data. So come check us out and learn more about the different ways in which we can implement this solution. Now, how is the enterprise solution, or what is it generally used for? So once again, I just like to reiterate that it's designed to optimize and automate Earth observation image processing pipelines. Once again, it's designed for any size, end-to-end or integrated. What we see most commonly is it's used for base map generation and DEM production, creating analysis-ready data, so ARD production, object detection and monitoring, so ongoing monitoring applications, and we especially see a lot more of those being deployed in the cloud, and then emergency response, where you need to quickly spin up some processing and then potentially shut it down for a while until it's needed again. So we've seen a lot of that take advantage of our on-demand processing capabilities there. What we are going to explore today in this webinar is the analysis ready data, so the ARD production. So this is what we're the rest of this webinar is going to be focused around, and how we are able to use our Catalyst Enterprise in order to automate this workflow. So we're really excited to show you that today. So let's very briefly provide a little bit of an overview about what analysis ready data is. So quite simply put, it is the result of taking Earth observation satellite imagery and turning it into interoperable. That's a very important term that we're going to be saying many times here in this webinar, interoperable measurements. So these are scientific reflectance, or what we call NBAR measurements, surface measurements, so that we can basically compare pixels and positions and the measurements that we take at different places in time for a specific geography or a specific position across a time series. The benefits of why do we want to do this? What's the value of converting our imagery into analysis ready data? Well, it's to allow for the immediate analysis of your imagery with minimal additional processing. So we're getting it to the point where it's of a certain quality, it becomes interoperable with other data sources, and it can be immediately consumed by, say, different AI models or a variety, or for time series analysis, and it's immediately consumable, so that you don't have to spend all that heavy lifting of all that time pre-processing the data. There's a common notion of the 80-20 split, where 80% of your time is in the pre-processing and 20% is in the actual analysis. So this eliminates that. It gets you to that point where you can immediately start performing your analysis. Now, why is this important? Why is this important now? So why do we need to start doing this now? Well, there's an overwhelming amount of data that's being collected on a daily basis. This is making it really difficult to analyze. It's actually not possible to analyze all of the imagery that we're capturing with Earth observation satellites using manual methods. An amazing quote from from IBM that we sourced was 90% of the data in the world today has been created in the last 2 years. Now that's an amazing just concept to think about how much data we're producing on a daily basis. Now, what does that mean in terms of Earth observation satellites? So right now in 2020, there's approximately 600 Earth observation satellites orbiting us today, with an approximate repeat time within any one of those constellations of upwards of 4 images a day. So we're already getting multiple views of anywhere on the Earth within a single day. But what we're expecting to see is, even in 2022, that repeat visit times, or that revisit time, is going to increase to 24 times per day, which means hourly revisit times. We're going to get imagery over the same positions on Earth on an hourly basis in 2022, and that's and it actually is just a couple and that's within an individual constellation. Now, also another thing to think about is in 2026, we're expecting the number of EO satellites to increase to 1,400 Earth observation satellites, which means that we're going to definitely see a sub-hour revisit time. So we're going to be able to get imagery and at a frequency that we've never seen before. So we need to have these pipelines and these processes established and automated so we can support this. Now, another interesting fact is artificial intelligence and automation are going to be absolutely essential to overcome this challenge of the amount of data that we're getting in. An interesting trend that we've identified is in 2018, the overall artificial intelligence industry worldwide was approximately 20 billion US dollars. It's expecting to grow by 2026 to be about $202.6 billion. That's a factor of 10 in terms of growth. So almost an order of magnitude in terms of what we're expecting to see the growth over the next 6 years. So it's a pretty interesting fact. So we're starting to see market analysts are already predicting that we're going to be really leveraging artificial intelligence going forward. So this is the trend we need to start moving towards. And how does that factor into our analysis ready data? Well, there is a need for, in order to support these artificial intelligence models, in order to support these, essentially what we're going to be building is these data pipelines where we're going to be pushing pixels through and having these workflows and these models automatically analyze and predict what's happening and what's going to happen on the Earth. But in order to have this data to be able to be effectively fed into these models, they need to be pre-processed to a certain standard. And that's what analysis ready data can allow us to do. So we can be able to process this data to a certain standard. So this is one of the key factors. Another critical component or another really important factor about why analysis ready data is so important is because of what it allows us to be able to do in terms of evangelizing Earth observation to other disciplines, so making it interdisciplinary. Now, there's a lot going on the screen here, so I'll just quickly break it down to you. What we ultimately want to do is make it so Earth observation imagery is more easily made available to downstream users, so that it's not just accessible to geospatial experts or people familiar with the domain, that other subject matter experts or subject matter experts of other fields will be able to use this information because what we can ultimately do is create it and it becomes just another measurement that they can introduce into their modeling, introduce into their analysis. So the way that this is kind of designed to look at is that we're doing the EO data capture. So this is the simply capturing the data. And then, the next step that we're really showcasing here today is the conversion of that data to analysis ready data so that it's available to, that it's been converted into these interoperable measurements that can be cross compared and be utilized by analytical models immediately. And then that can then get put into open data cubes. So this is another leading technology that we're seeing in terms of making the data more readily available. So once we put that analysis ready data into the open data cubes, then it becomes accessible by so many different people because all they need to do is just query the area, the location, the time that they want to get a measurement from, and it just becomes another measurement that they can then introduce into their analysis and into their models. So no longer do they need to be an expert or have a deep background in remote sensing or geospatial sciences. And then once again, just to help get the creative juices flowing. So just to show you case an example, of what we can do with an analysis ready data, automated analysis ready data pipeline is we have the ability of obviously going back in time and looking at how land cover has changed so we can perform and start to analyze when different objects on the earth or locations on the earth change to different types of features, which is what this map is showing. So you can see when these different pixels are actually objects, because we're using an object oriented approach. So we can actually see when these objects are converting from one land type to another land use type through time. But then what's really exciting about this as well is, of course, processing and analyzing this and understanding this in the past. But then as new data comes off and as we acquire new imagery, we can throw it through these pipelines. And in near real time, we can start to add it to these applications and start to have this sort of continuous ongoing change detection, continuous classification. So, also known as CCDC. And this is just one of many types of applications and use cases of what we can do when we have analysis ready data or a pipeline that is capable of creating analysis ready data in an automated fashion, which is what we're showcasing today. Okay, so I think it's time for a survey question so that we can get the audience, interact with the audience a little bit more here. So the question here is, what is your interest in analysis ready data imagery? So in this one, it's a multiple field, so it's a multiple choice question, and you can check all that applies. So give me 2 seconds, and I'm just going to launch this poll question here. Okay, so it should appear on your screen now. So once again, the question is, what is your interest in analysis ready data? So a couple of the options are you can create analysis ready data imagery for use within your own organization. You're trying to create analysis ready data for use for public consumption. So you want to create these archives. You want to create and sell analysis ready data imagery from new acquisitions. So perhaps you work with a data provider or you're working in the sales channel of the data provider. Or you're just you want to use ARD image for your own analysis or for to be able to support the analysis of your colleagues. And finally, you're just here to learn. You're curious, you've been hearing this buzzword ARD and you just want to understand a little bit more about it. So very curious to hear your answers. So we can already see that we're getting a fairly large number of people. So about 63% of you are saying that your goal is you want to use ARD imagery for analysis. We do have also 31% that's saying that your goal is to create ARD imagery for use within your organization. And then the rest seems to be, and then many of you are also just here to learn. So wonderful, really appreciate that. Okay, so we have already collected majority of the votes. So I'm gonna close down the poll. So if you can please get your question or your responses in the next 10 seconds, because I'm gonna close the poll in 10 seconds. And okay, so 3, 2, 1, and I'm going to close the poll. And let's just look at those results very quickly so we can see once again that at 30% we have you're looking to create ARD imagery for use within your organization. 17% are looking to create ARD imagery for public consumption. 10% looking like you want to create and sell ARD imagery from new acquisitions. 67% of you look to use ARD imagery for analysis, and 43% of you are just here to learn. So that's great. Really appreciate that. All right, let's continue moving through our presentation here. Okay. So I want to drill a little bit deeper into what analysis ready data is and what our solution for creating analysis ready data is. So really we break it down into 3 main components. So there's a lot of activity happening within each of these components, but we can break it down to these main pillars here. So we're doing geometric correction. So what we're essentially trying to do is make sure that the position of your pixels are in the right place. So this has been an area that we've have been historically very strong in as well. But we've recently released this new capability called super registration. And what this allows us to do is to take already orthorectified imagery where there is no associated math model to it, and we can further correct that imagery and get it to 1/10 or even better of a pixel accuracy. So this is one of the values of this of our geometric correction workflow. So we fully automate this process and take it right to the point where you have these perfectly co-registered image stacks that can then go into the next stage of the processing pipeline, which is the radiometric correction point. So this is also very important. So what we're doing here is radiometric normalization of the imagery. So we're really correcting for atmospheric effects as well as bidirectional effects and terrain effects. So the outcome of this is producing what's known as a surface N-bar measurement, so a reflectance measurement that generally, oftentimes we scale it so it can go into a 16-bit image, but basically you're getting a reflectance image that can then be compared to other reflectance images or surface N-bar measurements rather. And then finally from that, we then do product packaging. So we're packaging based on Card4L product specifications. So this looks at product formatting, encoding, generating quality layers, and the proper metadata formatting. So that once again, when you compare the Card4L ARD imagery with other Card4L ARD imagery, they're immediately interoperable. So they can immediately be compared with one another. So let's take a look at a subset from a larger project that we're working on right now. So once again, we worked with, actually in this subset, it was that we analyzed was 727 commercial satellite images. So it's just a small subset. So we're actually working with, one of the space agency right now, and they have a huge archive of imagery. And basically, we were working with spot imagery from spot 1 to spot 7. So it's a variety of different apertures and sensors themselves. And we're looking at imagery all the way captured back as early as 1990, all the way up to 2000, or basically today. So the results of this subset project was overall, so between all of the old spot 1, spot 2, all the way up to the spot 6s and spot 7s, was an overall circular error 90 of 0.13 pixels. And we had and that's for the positional accuracy. And then for the radiometric normalization and accuracy, we had a 0.91 mean R squared result, which showcases a very high absolute accuracy when we compared it with the MODIS imagery of the same period. So Catalyst Enterprise, once again, for ARD. So looking at who is this really for? We have governments and organizations with image archives of all sizes. So essentially, you can imagine you have these archives that have been, you have either just recently started or you've captured for decades now of imagery from a variety of different sensors or from a single organization. And right now, it's you've used it in the past, perhaps for creating base maps, for doing certain bespoke analysis. But what we can do working with you is we can help breathe new life into this imagery. So by being able to convert your existing radiance imagery into N-bar surface reflectance imagery or measurements, you can then now make it more widely available to other, say, government departments or other departments in your organization that don't have a geospatial background, and they can start to leverage the information in new ways that they've never were able to do before. The other benefit is imagining that if, for example, you have a individual that wants to be able to perform a project or use the data for analysis, if you don't have the ARD measurements already, then it becomes a quite expensive project for them to be able to take advantage of those pixels. They have to hire somebody or bring in somebody into the project who has a strong geospatial background to be able to do the pre-processing. There's a lot of time and software acquisition that needs to happen and time to produce the data before they can even get to the analysis. So this is one of the benefits, and because it's an automated process, from end to end, really that's just going to save a lot of time and save a lot of money and a lot of resources to be able to generate this analysis ready data. Now, on the other side of the equation, we have the satellite distributors and providers of newly acquired imagery. So you can imagine the ability to, say, stand up our Catalyst enterprise in the cloud and being able to build a automated pipeline where the data comes through, you perform certain levels of processing, and then we bring it to the point of an analysis ready data. And now you have a value added product that you can either distribute or make available through your cloud services or different platforms. Once again, looking at the Catalyst Enterprise for ARD, so what are some of the major benefits that we want you to walk away from this with? Understanding is automated and scalable. So I can't emphasize that enough. Getting to the point of creating a surface NBAR product, so creating a surface reflectance product. I mean, many of you have probably used a variety of different atmospheric correction tools in the past. They require an incredible amount of knowledge, an incredible amount of sophistication, and a lot of time, a lot of reference information. And it's a very tricky task to be able to do. So we have it, what we've done and the investment we've made over the last few years is to figure out and define a way to do this in an automated fashion that creates a quality to a level that is is built around the card4L specifications and rigor. The other thing is the sensor agnostic. So we've built this out so that it can be used on a variety of different sensors, so commercial and public. So we've already have off-the-shelf capabilities for some sensors. For other sensors, we already have there might be some optimizations we need to do with those sensors, but come speak to us if you have a particular sensor, whether it's a commercial or it's a public sensor that you'd like to convert into ARD imagery. It's designed based on the card4L specifications. So this in our mind is really the gold standard when it comes to ARD imagery, comes to the specifications and the compliance required around it. And this is all defined by CEOS, which is the non-governmental, or actually or a non-governmental entity that involves many different nations from around the world that are all coming together and agreeing upon what these standards and specifications should be. And also low cost of entry. So once again, using the different platforms and methods that we have and the different ways of deploying this technology, we can come and find a solution that'll work depending on your needs and work for you. Once again, just want to reiterate the fact that just that almost that last point, which is that it's very scalable. We really wanted to reduce and eliminate those barriers of entry to be able to generate this kind of information. It's subscription, so it's all doesn't have to be a lump sum upfront cost. So you can spread that cost throughout your operational expenses throughout a period of time, and that period of time just depends on how quickly you want to convert your archive to ARD imagery, or how much imagery you want to process, or what kind of throughput you're looking for. We can deploy it in a variety of different platforms as well. So before we go into our demonstration, which is up next, I just want to open up one more survey question, and then I'm going to pass things over to Jason, who's going to showcase to you our Catalyst Enterprise ARD workflow. Okay, so I've launched the question, so I'm just going to read it. Basically, what type of imagery do you mostly work with today? So really just looking for whether you're working with commercial data, are you working with mostly public data, or do you work with both? So whatever comes across your desk, you'll work with. Okay, we've seen already over half of you have already voted. We'll give it a little bit more time. So we're seeing majority of the people, already about 50% of the people are saying that they work with both, followed by public at about 25%. And then there's a few people at 21% that seem to exclusively work with commercial data. So, okay, at this point, I think we're going to give 10 more seconds, and then we're going to close the poll. So if you haven't got your vote in, please get your vote in now. So we're going to shut things down in about 3, 2, 1. Okay, I'm going to close the polls now. So let's just quickly share those results so everyone can see. So as you can see, we finished off with about 55% use basically whatever imagery had come across your desk. 24% are working exclusively with public data, and 21% seem to be working exclusively with commercial data. Okay, so with that, I'm going to hand things off to the star of the show. So we're going to hand things off to Jason Platt, and he is going to provide you with the demonstration today.
Thank you, Sean. Let me just share my screen. Trying to make myself the presenter. There we go. Great. Can everyone see it? Wonderful. So hello, everyone, and thank you, Sean, for introducing the topics and explaining the ARD workflow and technology. So for my demonstration, it's going to be made up of 3 different parts. First, I just want to showcase the automated ARD workflow in the Catalyst enterprise system. Then I want to explore the accuracy validation, and as Sean alluded to and talked about with the radiometric accuracy and the geometric accuracy. And lastly, I want to just explore how users can actually work with ARD imagery in an open data cube concept. So before I move any further, I would like to just showcase just one of the example images that we processed over South Africa, Spot 5 imagery. As we can see, it's a surface N-bar product. We have all the radiometric coefficients available. And this, along with the rest of the data stack, will then be used for the analysis. And of course, all the raw images were then processed through the workflow, the ARD workflow. Lastly, all those images can then be used in systems like the change detection over the neighborhood that Sean explored previously. So now for the demonstration, I like to just open up Catalyst Enterprise. I'm just going to select the system itself. For this demonstration, so after accessing Catalyst Enterprise, which is formerly known as GXL, we see there are 3 fully automatic workflows associated in the ARD workflow system. This contains the multiple tools and operations necessary. The first one is the geometric correction. So the ingesting, the ground control point collection, the orthoing, and that new super registration technology to align the images. Then the automated spectral normalization, so to normalize the images and the imagery. And then lastly is to package it following the card4L specifications, and following all these 3 steps, makes all the images interoperable for use. And of course, all of these can be chained to a complete end-to-end workflow. So I'm just going to quickly select on the first workflow, the geometric correction. We have a number of different input parameters. The user could set scene, location, DEM, reference image. I've already set, I can already set the parameters. I have a XML document with it just for ease of use. I'm going to then submit the job, and this is going to now automatically identify all the images. Starting now, it's running through the library. And I'm going to select ready. And right now, what we're working with is this Catalyst Enterprise system has access to 3 processing servers, 2 of which are paused. So we're only working with a single server. And what we could see, it's already searching for scenes. I'm going to select running or waiting. Or let me just check one thing. There we go. We have just a few images running, but I can then turn on the other processing servers. Here, let me just check one thing to make sure. I could turn on the processing servers, which will speed up the job. Let me just quickly select one thing on the. Okay, I'm just going to rerun that. There seems to be a quick hiccup. And there we go. Alrighty. Sorry about that, everyone. Just going to import it again. select submit. It's going to load. And in the meantime, I'm going to showcase just the processing servers as well. On the right, we have one of them is active and it's starting to run. It's starting to identify the images and it's going to get to full load. And I'm going to turn on the other two, the 3 and 4. And we're going to just see in just a second, searching for scenes, running and waiting. I'm going to turn on number 3, setting it to active. Perfect. So what we can see immediately is that once I've turned on the server, 10 or 5 additional images have been identified and are starting to process. And I can do this for the second server as well. So now from 5 to 10 to 15 images will then begin to be processed. Now for ease of use or for time, I'm just going to showcase the final product once the entire workflow has been completed of what we're going to have. We're going to have our spectrally normalized to NBAR folder containing all the spot images, so the multispectral, the panchromatic, associated with their XML document as well, which contains all the necessary metadata required for those card4L specifications. And lastly, we also have a quality summary report, which is generated, which lists every single image processed in the workflow, its geometric circular error, or the shift in circular error, 95 or 90 to the reference image, and the radiometric accuracy R² to a MODIS image that was used in the normalization. In addition, we also offer users the ability to set their own conditions for tiering so it can identify images based upon different tiers so users can select certain images for their analysis. Just going to minimize that. So now we can explore the different types of validations. We've now talked about just how to set up a Catalyst workflow for the enterprise solution for the ARD. And we now have seen the outputs, but let's actually go into the validation set. So I'm going to select this focus window in here. And what I've done first is I took that accuracy assessment report and plotted every single image and their associated circular error and radiometric accuracy and for the specific sensors. And what we can see is that geometric circular error 90 is on the x-axis in pixels, and on the y-axis is the radiometric accuracy, and it's R². We can see that there is a good distribution of all the images once they've completed their ARD process to have a high radiometric accuracy, but also a low geometric error. And as Sean mentioned before, the mean radiometric accuracy R² is 0.91, and the circular error 90 is 0.13 pixels. So now we can explore more of the granular approach of looking at a few images that were used in this process. And so I'm going to select on the geometric correction, and what we can see is just the reference image or the control image that was used to collect the ground control points in the geometric workflow. And I'm just going to showcase just an example of one of the spot 2 images that was processed in its raw form. And I'm going to select it, and we can see if I zoom into the harbor over here, in the raw spot 2 image with its original capability, we are significantly shifted away out in the ocean. And so I'm going to turn that back off. It's just loading in a second. And I'm going to showcase the final output of the super registered in just a moment once it's done loading. There we go. And we can see we have sub-pixel alignment to the harbor. So from a huge shift of kilometers away, we've improved it quite significantly. Next is the radiometric. And so what I did for the radiometric analysis is I generated a change detection between the N-bar products that we created in the ARD workflow. And I also performed a change detection of the same images with top of atmosphere reflectance values. And the idea is I selected areas that are consistent, that do not show a lot of change, spectrally stable, such as roads. This is an airport runway area. So these are areas that shouldn't be changing too much radiometrically, even though it's the images I'm looking at are from 2013 and 2009. So I performed the change detection, I calculated the magnitude of change, and then I divided that to collect a percentage. What we can see here, if I zoom in, this is just one small little area I selected of the other polygons I created to create this metric, is that the greener the pixels are, the lower the changes in the spectral radiometry between the different dates. And so with our spectrally normalized N-bar product, we can see that there's a minimum low change. So it's very green in this area, which is great. That's what we expect since they've been all radiometrically normalized. However, if we looked at the top of atmosphere reflectance instead, using the same scaling and the same representation, we can see those pixel values that change is very high, very red and orange. And so that is something important for us to understand. So what we see in this little relative comparison, that the normalized data demonstrates the interoperability of image measurements from the different dates. And by us reducing the noise, the consistency enables users to perform their analysis across time and be able to make meaningful measurements. So these are just two little ways we can showcase just the validation of our results. But now I'd like to explore how can a user actually access the data cube. And so we can showcase this using the data cube Python library in a Jupyter notebook. I'm just going to select that right now as the GXL or as the enterprise system keeps on processing. So what we have here is this notebook demonstrates how to import a time series of cloud-free spot images that were processed in the ARD workflow. So spot 1 to 7 in a data set, and then plot the data as a time series. So what we first see is we can import all the libraries necessary, identify an area of interest that we want to perform our analysis on or our time series on, extract cloud-free pixels, and then we're able to create or acquire the images themselves. We can plot different images as well, and even create animated GIFs of the change occurring. However, we can even perform additional analysis, so we can extract indices such as an NDWI as I scroll down, and we can represent it in different ways, but also we can even track it and monitor it using our own graphing, the graphing system as well. And all this these are just ways of users analyzing and accessing the data. So because in the data cube and the ARD imagery have standard measurements, anyone can use this and combine it with other data sources. The strength of the Jupyter Notebook enables users to explore the data cube, to analyze the imagery, and then make meaningful interpretations that can then be provided to the public or decision makers. And of course, there are many more different tools and libraries that can be accessed in, for instance, this Jupyter Notebook to make extract more meaningful pieces of information. All back to you, Sean.
Wonderful, thank you very much. Okay, so I'm just going to share my screen here today in a second. Okay, so this pretty much concludes the webinar for the most part, but we're going to open up the Q&A section of this webinar now. So we'd love to, if you have any questions, we would love to receive and have the opportunity to interact with you directly. So I'm just going to turn on my webcam here. Okay, so people can see me again. Uh, so we already have a couple questions that have come in, so I'm going to just address the first one. So the first question that came in was, does the ARD workflow exist in Catalyst Professional in their modeler or in Python? So that's a great question. So the algorithms required to create analysis-ready data does exist within Catalyst Professional. But what we've done here with Catalyst Enterprise is we've basically created the glue and the automation that allows this to be so powerful. So the ability to go from end to end by just simply setting up a couple parameters, pointing to your input raw imagery, and then being able at the other end to generate all of your surface NBAR products. So that's what we've done with the enterprise solution. But the actual algorithms that you would need to sort of create your own pipelines do exist in Catalyst Professional, but you would have to then, connect them together. And once again, you're missing a lot of the science that's involved to automate it. So that's what is the value that the Catalyst Enterprise brings. Okay, I'm going to look at another question here. So it's going to extend it. So another question is there interested to understand the space and time and the resolution you can reach with analysis ready data. So as mentioned, this solution is designed to be sensor agnostic. So we've deployed it already for medium resolution sensors, commercial sensors, and but it's of course very capable with some sensor optimizations to be able to deploy it for really any resolution. So this is something we would love to chat with you about and learn a little bit more about what kind of sensors you're working with and what kind of data you'd like to process. And in terms of the data set for the project that we were talking about, we've basically built workflows and automation for working with data as the data that we've worked with so far is as far back as the early 1990s. So that's a great question there. So a couple more questions coming in. So can the generated ARD be imported and used in Open Data Cube directly? So we actually have our ARD project manager on the line right now. So Jean, I don't know if you're able to get your audio going, but perhaps that'd be a great question for you to answer.
Absolutely, Sean. Good afternoon. Hello, everyone. So the question is, can the generated ARD products be imported and used in the Open Data Cube directly? Is that the one?
That is the one, exactly.
Yes, okay. Yes, it can be. We do have tools to help you index your data and import and move that data into the Open Data Cube, working with the Data Cube library.
Wonderful. Actually, this is another great question for you. So the question was, I noticed in the demo that PAN and MS images were sourced. How do you treat those PAN images with respect to MS imagery?
Sorry, said it like in terms of what portion?
So, I mean, the question was just more around, I guess, so are we using the PAN and MS imagery? So I guess, how can we work with the PAN and the MS imagery? So for example, this is my interpretation of the question, but for example, with Landsat, for example, you can only get the MS imagery and analysis ready data. So because we have access to PAN and MS for certain sensors, are we able to take advantage of the resolutions of panchromatic and generate, say, ARD for pan-sharpened imagery? Is that possible?
Yes, it is possible. So a few ways I can answer your question. One, we use to process a lot of the pan imagery, we use a lot of the multispectral information. We have developed technologies to simulate certain values that overlap spectrally the data that we need to process. In terms of getting an ARD pan sharpened product, we have developed technology for pan sharpening that imagery and preserving as much as possible the spectral values, so having a high spectral fidelity. And we do that using a sort of a pan sharpening technique in the multi-resolution analysis family of pan sharpening techniques. Yeah.
Wonderful. Okay, I think we have time for one more question. So it's, can you give an example of what is included in your data pipeline, such as for Sentinel-2 or other sensors to get ARD products? So once again, our solution is sensor agnostic. Depending on whether we've already built out the solution for another project for a specific sensor, it may be already available and we've already optimized it for that sensor. If it's one that we haven't directly worked with yet, then there would be some optimizations required for that individual sensor. What's included, there's actually a lot of algorithms under the hood that are being used. And as Jean-Sébastien actually referenced, we, for example, work with, we have the ability to generate pan-sharpened imagery. But of course, as we showcased earlier today, we're working with a variety of tools for the geometric correction, such as automatic GCP collection, tie point collection, but then the new super registration algorithm for getting that final, less than 1/10 of a pixel accuracy for ortho images that don't have a math model with them. Same thing with the radiometric normalization, so a variety of capabilities to correct for atmospheric and bidirectional reflectance distribution effects. So there's a variety of different tools in there. Also creating just the packaging of the imagery so that it meets the or towards the card 4L specifications is another part that we have in that workflow. So there's a lot that goes in there, and there's a lot of science and a lot of testing that has gone into this workflow. And once again, we would love to continue these conversations, and so reach out to us if you're looking for more information. A couple great resources, so you can go to our new website at www.catalyst.earth. If you're looking specifically about analysis ready data, so you can go to this link here, where it's catalyst.earth/technology/ARD. And yeah, we look forward to reach out to us, and we would love to have these conversations with you to be able to educate you and learn more about what you're looking to do with analysis ready data. So with that, I'm going to close things off, and I'm going to like to really thank our star of the show, Jason, today, and also Jean-Sébastien for helping field some of these questions. If we didn't get a chance to answer your question, we will follow up. So we will follow up within the next few days in order to and send out a response to all the questions that were asked. So once again, thank you very much for being with us here today. We hope you have a wonderful holiday period over the next couple of weeks, and we look forward to engaging with you in the new year. Thank you again.
Happy holidays, everyone.